Okay, so we have Chris Kuethe, who we've invited to talk about our audit tree modules. We've mentioned this before. We have CGRAN and this audit tree project concept. There's a ton of stuff out there, and Chris has actually been really prolific in providing us with PyBomb recipes to get more and more stuff out there. So he's just going to go through a handful of examples and ideas of what's going on out there.
Pretty much. I called this Squirrel after my tendency to get really distracted by all these modules that I keep coming across and cooking up demos and realizing that as I'm constructing a toy test case to do something, this solves one of my project needs, and then I go off and get distracted, and that's why I didn't get my slides done until just about now. So yeah, squirrels on a satellite dish. I couldn't find any squirrels, chewing on antennas, so that's the start there. Tom's right. I have been kind of commit storming on the PyBombs repositories to the point of having come up with a script to automatically go screening through my working repository directory, automatically checking out the repository, importing a new recipe, tagging it, pushing it to GitHub, and then doing this all in a big batch because I'm starting to wear holes in my keyboard doing this. So here, where you get your squirrels. I didn't do up a demonstration of GRGSM. That's one of the next things I really want to try and understand. But you can see there's tons and tons of modules. I clipped the scroll bar off the side of the screen. But there are a lot of extra modules that you can add. When I was starting to label them, I decided, and something goes in as an application, if you could reasonably tell somebody, yes, just go to PyBombs, install the thing, and it works. So dump 1090, ACARS deck, GQRX, all the sort of things that an end user would want to just run it and visualize goes into applications. There's a bunch of hardware abstraction layers like UHD, Osmocom, whatever else in hardware apps, and then all these other little modules that you would build more complicated flow graphs from just within Common. And on that note, CGRAN preloaded. CGRAN died a horrible hardware death. And lucky some of us kept backups of the Subversion repository, and over the last few months we've been pulling things out of the repository, reviving them on GitHub, and there's been a huge amount of work into automating this process. So there's a manifest in most of the out-of-tree modules that describes briefly what the module does, who wrote it, what license it is, where it can be found. So CGRAN now just automatically parses those. There's some magic on the backside that looks in the PyBombs repository for the existing recipes and generates this web page. So shortly after a new recipe arrives, it's visible here on CGRAN. And very likely the most important module that anybody's going to have from out of tree is GROsmocom, because without it, probably most people won't be getting any signal into their instance of new radio. So GROsmocom will talk to all four of those receivers there at the same time. I've got my B200 tinfoil wrapped hack RF, because otherwise I get a huge amount of leakage into it, an air spy, and a cheap little $7 tinfoil wrapped RTL SDR. And there are a ton of knobs that you can pass in. Some of them do things that you would expect, some of them don't. One thing I dislike about GROsmocom is its lack of introspection. So once the flow graph starts running, it has no way to tell what sort of receiver it's communicating with. And that can make it really difficult to have your flow graphs do intelligent things based on receiver type, like automatically setting gains to something reasonable. And there are some other things. All of those nice tags that UHD provides are not provided by Osmocom, and so we'll probably get around to rage fixing that on Hackfest on Friday, because that gets in the way of some of my stuff too. So a few of the things I wanted to look at were related to instrumentation. for the inexpert user, and I will claim to be one of those, it's not always obvious what's going on inside my flow graph. I like plug modules together like I found on somebody's tutorial, and I keep getting garbage out. And sometimes you can put print statements into your flow graphs and have the Python print what it's doing. It's less obvious if you're using a C++ module. So typically my solution there is to just tap various signal paths with a GUI sync or an audio sync if the bit rate is low enough. And then I found GR display, which is vastly preferable to opening a file sort or a file sync on Dev standard out, because if you're trying to tap 5 or 6 byte streams in your flow graph, you're going to get this set of file syncs scribbling over each other, and they won't be able to tell what they're doing. With a text sync, you get these nice windows that nicely give you a scrolling view of all of your bytes going by. Tim was kind enough to produce GRPyQt and the message debug block, and I used that an awful lot while I was debugging a GPS interface module that I wrote, so that I could say, okay, the messages that are coming out of this flow graph, what did I just generate? Does this contain valid data? Does this contain something meaningful? So I take the message input, dump it into a message debug block, and I get very clear, easy to understand messages. And then phosphor. You've probably seen a few instances of this. This is the new hotness in waterfall displays. It takes advantage of hardware acceleration wherever possible. So even on a laptop, you get easily hundreds of frames per second. You don't have PyQt waterfall, or not PyQt, just Qt waterfall dragging down your CPU. This is all offloaded to my GPU courtesy of OpenCL. And I think I actually got all the right dependencies in the recipe for calling OpenCL, so this can be chewing away at many megasamples per second and leaving my CPU free for useful stuff. So once we visualize that there are some interesting signals out there in the spectrum, you might want to start actually cracking those out, parsing them. So what's up, doc? And people much smarter than me have put a lot of effort into writing some of these. Some of my favorite ones to play with and at least whet noobs' appetites with are things like GRADSB. A lot of people are running ADSB monitors using DOMP 1090, which is a simple little text mode ADSB monitor, but we can do the same thing inside a GR flow graph. So in this case, we just take whatever source we've got, feed it through a conversion to magnitude. The threshold block, the levels here were quite empirically determined, so if you're getting garbage out of your decoder or not getting anything out, that would be a fantastic place to put a time sink and see what are your output levels and see if you need to adjust your threshold block or your receiver gain appropriately. You can also then tap the output of the correlator and trigger on the ADSB preamble tag, and then you get a nice little graph of the bits that only refreshes when a valid message comes in. And that looks sort of like this. I just monitored a few aircraft going by my place yesterday. You can see that not all the ADSB messages contain all of the fields. There are a number of different formats that are output. And the reason I wanted to have JSON output was so that I could then hook this up to Twitter and write a bot that tweets every time a TCAS alert goes off. Collins is probably going to tell you a whole lot more about ACARS tomorrow and his AV mapper, but briefly he's said before it's like SMS for aircraft, and it's either talking about engine diagnostics or reporting broken lavatories. So 2 airplanes reporting broken lavatories, and check engine lights. And this is not very easy to read because it's this particular decoder doesn't do any nice pretty printing, but you can see that there is some legible text from my local airport, something about Eric and SJC and Fairground Visual. So there is stuff out there.
Can you speak about that audio sync?
Oh, yeah, and the reason I put the audio sync in there was because I wanted to listen to the ACARS at the same time. So it's just an FSK signal. It sounds like a little squirt of modem or pager. So I was just listening to it at the same time as I was printing the text. And that was also helping to validate that I was getting possibly decodable data instead of just radio noise. And then Phosphor is a pretty awesome visualizer again. I actually decided to try document the polyphase channelizer because I wanted to decode all of the different ACARS channels. There's a dozen of them or so running in various parts of the world, and I wanted to come up with a unified flow graph that, given a competent enough receiver like an AirSpy or HackRF or USERP, would be able to pull the entire spectrum and then break out all of the channels and give me simultaneous decodes of any ACARS channel. And so along the way, I figured I needed to learn about the polyphase channelizer and then visualize it, and that actually helps me understand the polyphase channelizer and why you need that one extra channel. Then inspired by Tim's UHD GPS, I wrote a little GRNMEA module because I would much rather lose a Raspberry Pi RTL SDR and a USB GPS in an airport than I would rather than my laptop. And having lost a laptop in an airport before, it's not fun. So yeah, spending a couple $1,000s to get a new laptop and a new user, or $100 to get a new, cheap kit, I'll get one of those. But GRNMEA was just a little Python module to talk to serial devices, serial NMEA GPSs. And if you have something other than that, you can use GPSD, and I know that's going to be supported because I have about 2 cubic feet of GPS receivers at home from my involvement with the GPSD project. So if you have any other protocol other than NMEA, just run it through GPSD. And that will also get you the advantage of having automatic time synchronization so that you can then use GRNMEA to timestamp your recordings and to inject position, velocity, and time tags into your spectrum streams. So not as good as USERP, but you can cram a 15,000 milliamp hour battery brick and a Raspberry Pi and a GPS and an RTL into your cargo pants pocket and go for all sorts of interesting salient blocks, and nobody knows what you're doing. Okay, so we've got data out of the world and into our flow graphs. Sometimes we want to generate flow graphs and put things into the world. And not everybody's meant to read everything, so I was quite pleased to see GRNACL. That was just a quick finding around the NACL crypto library, and it's super quick demo. I have a known text string. I decided to run it through a throttle block so I wouldn't kill my CPU in the process of making the slide. I turned it into a length tagged packet, feed it into a crypt stream, and then a crypt stream again with the same keys, so that decrypts it. And we can see that we've got plain text in, scrambled ciphertext in the middle, and plain text back out. It works, it's just that easy. But the only thing I want to change about that is the documentation for the key and nonce parameters. It was not entirely obvious without reading the source that the key has to be 32 bytes long and the nonce has to be 24. So, range documenting them. GRMX a lot. That was kind of funny. Somebody posted that in the radio channel. and they were saying, I can't make this work on my Mac. And so, well, there's your problem. You're using a Mac and fighting with Homebrew and Mac ports and something else and libraries stomping all over each other, but in the process of validating that that Mix-a-Lot was in fact doing what it was supposed to. I used this little graph and transmitted a simple little page that was then correctly decoded by Multimon. I'm not entirely sure whether I want to do a recipe for Multimon or if it stands alone by itself. Most of the repositories get it right, so I don't think I need to do a recipe for it. But anyway, it's super easy now to generate pages, and I hope Paul doesn't see this next time he goes to restaurants that have pictures for the tables. And then you probably also saw on Hackaday and the like that, courtesy of Chaos Computer Camp, somebody had come up with a tool for generating arbitrary spectrum plots from pictures, and Dr. Nkeg decided to turn this into a new radio block. And so one simple block takes a picture and does that with it. So an interesting thing is I actually had to take out a bunch of padding because the phosphor sync runs so much faster. I actually had to pad it to get it to have that same picture size, whereas the QT sync clocked identically. I had time to get almost 4 copies of that image in the same space as the new radio, so it's running 32 times faster easily. So basically, you can now scribble Doge pictures all over the spectrum if you so like. I will probably do up an extra block to use Python imaging library to automatically convert an arbitrary image file as understood by Python into a bit stream, and you don't have to use the intermediate target to luminance program. Or maybe I shouldn't do that and make the spectrum vandalism a little harder. Next thing is basically check out all of the modules in iBombs, install them all, and then start plugging modules together. Some of it's going to break, some of it won't. Some of it will produce garbage results, some of it will produce meaningful results. Start throwing visualization syncs on and see what comes out, meaningful or not. Tom has started up a repository of sample photographs, and we'll be publishing some in there as well, of examples of how to use every block, because I learned an awful lot about blocks coming up with this presentation and finding places where the documentation is not obvious. It's clearly possible to figure out how to use all these blocks without posting cries for help in IRC or mailing lists, but that's no fun, and we'd rather have clear working examples. So we will be adding more of those to GR samples and CGRAN. And anybody who wants to join us can join us in Pound Community Radio or Pound Cyber Spectrum. And I'm on GitHub and very rarely actually listening on the air. Questions?
So I've got a challenge for people sticking around for the rest, or for especially all like the speakers that are coming up. The first person who does an entire presentation with GR Paint for your slides gets a free T-shirt.
Well, geez, had you told me that? Oh, actually, I can just transcode them and.
I know, actually pretty easy, but I know it's chance to give away for various things like that. This actually brings me to an interesting point, right? What Chris was talking about with the documentation. He said he was having trouble with the polyphase filter bank, or the polyphase channelizer block, and getting to use it. I wrote that block.
And you wrote what, 4 papers and 3 conference presentations, yes. And I read them all,
and it's still, right, so this is the problem. I thought the polyphase filter bank code blocks in Mute Radio are very well documented, at least, I thought they were very well documented. The problem is, I worked on developing the polyphase stuff with Fred Harris and Bob McGuire, and like we were doing like the low-level math and understanding this stuff from a math perspective and coding it up. So by the time I was done, I was too close to it. So I've been writing things about this from the perspective of you are already an expert and know what a polyphase channelizer does and how it works and what the filters and all that stuff mean. Not coming at it from the perspective of that user, of what does the user need to know. That's the difficulty of being a developer and getting that documentation out there, which is great when you have somebody like Chris who's willing to, as he says, rage document, right? I don't understand this. Why doesn't this make sense? Now it makes sense, let me actually write the documentation and help the project. So I think that kind of iteration is going to help us as developers because we just get too close to the code.
And I don't actually mind, writing a few FAQs. So if stuff is unclear, send me a question. I will try to figure it out, and then try write, the final man page on it, so that nobody ever has to ask that question again.
Yeah. Yeah. So when you answer a question, you feed back to us, we will put it in. I mean, I think that's going to be a huge help to us in the project. But let me hand over to questions from the audience.
It's a little more to say nice. There's nothing wrong with using a Mac if you want to.
I chose to.
You can use one or the other, and if the software is written properly, it'll work on a Mac too. It really will. There's nothing wrong with it.
My new radio installation from MacPorts works. I know the individual who was having problems was also trying to use Homebrew, and between Homebrew parts of this and MacPorts parts of that and system parts of some other things, just too many things stomping on each other. But in order to rule out a possibly busted module, which has happened, I had to fix them. I figured, all right, I'm going to try it and make sure the module at least does what it's supposed to. So, yeah.
Any more questions?
You mentioned using Osmo, Osmo SDR for communicating with Edis products.
Yep.
What is the advantage of using that over just using the GR-UHD module?
Less having to come up with special case flow graphs. If I can have a single flow graph that starts with the GR Osmocom for signal acquisition or ends with GR Osmocom for signal output, that makes my life easier. Then I don't have to maintain two separate flow graphs and remember to port a change from one to the other.
Yeah, we'll say that's a trade-off, the ease of moving between hardware systems, as opposed to some of the benefits of using GRUHD, which provides like those tags, right? The time and frequency and sample rate tags come from GRUHD. I don't think they come through GR Osmo SDR.
Nope,
so there's that. There's also message passing control to the UHD blocks, so you can actually use messages to change the frequency or gain or LO offset. And those things aren't readily available; they're not available through GR Osmo SDR. So depending on what you're doing, you can do a lot with GRUHD for UHD devices, or you can, if you don't need that, and you want the flexibility of, all right, I'm on the road and I brought my hack RF, I plug that one in instead. Then you get that kind of flexibility.